This is Vic Smeed's book on model boating. Vic Smeed was a British model engineer. But I think you could make an engine from this. So I'm going to work on the flywheel. The drawing on that part is right here. So I've got to drill the center hole and the throw, which will be half of the stroke. The stroke's going to be a half, the throw will be a quarter. So I'm going to lay this out on the surface plate, show you how all that works. Okay, we're over here at the surface plate. This is a piece of granite that is ground exactly accurate on the surface. Something like 1/10,000th of an inch. And you can measure that. That surface becomes your reference, and you measure up from that, and you can accurately mark out your parts and where you need to machine stuff. So I'm going to lay out the flywheel. You could do this if you have good eyesight. You could probably do this with a rule and a punch. So I've got a pair of small dividers to make circles, and then I have a this is a spring-loaded punch. I don't know, sometimes they jump and they don't make your hole where you want it. Then I've got a real fine punch and marking tool. Got my rule, proper nomenclature. Then I love these 1, 2, 3 blocks. I got a pair of these, so they're exactly square on all edges, and all surfaces. And then I've got a real tiny machinist square. Then I've got an angle plate. This is a 90-degree angle plate for laying stuff out. The other thing I use is a pencil and paper for doing the math. This is the height gauge, so it measures the height above the surface plate. Surface plate and a height gauge. Some guys can just use the hand wheels, or if they have a DRO, they don't do this. They just do it all on the mill table with a digital readout, a DRO. Makes it easier. But this way you have something to shoot for. If you're dialing in those dials, even with a DRO, if you're dialing them in and then it's way off from where your marks are that you laid out here, you know something's wrong. Either you laid it out wrong or you dialed it in wrong. So this is really a good way to start any project. And when I was laying out the water witch, I never laid it out. I just started cutting, and I didn't know that. And when I went to my friend Bob Verhaeg and visited him, and he said, I know you have some trouble with this. I can see you have trouble with your engine. I couldn't get it to run, much less to work or run. He goes, I see you're having some trouble with this. Did you lay all this out on a surface plate before you cut any metal? I'm like, oh, what? And it was a surface plate, and he laughed, and he brings out his surface plate, and he goes, you have a height gauge, right? And I'm like, oh, what? So thank you to Bob for teaching me this, and it's the way that the machinist, he's a trained tool and die maker, and this is what the basics of their trade is, to get it laid out and marked before you cut so you know where you're going. The first thing you want to do is get this height gauge 0. You want this plate, you want it to read 0. So this is kind of a cheapy one, but it has an adjustment here on the plate. And of course you can get digital height gauge, very nice. A little pricey, but very pricey actually. So you want to consistently to read 0. So I don't know if you can see that, but I got it right on 0 now. So let's just see. Let's come up. Here's the 1, 2, 3 block, and they're an inch thick right here. So let's see if that goes up to 1 inch. Look at that. Right on it. So anywhere on this height, anywhere on the surface plate, it's going to be accurate. So if you have a larger part, I laid out the crankcase for the little Panther Pup 4-cylinder right on here, and it came out really well. That's just to check it. I'm using the 123 gauge. Now it has a tip brazed on here that is hardened metal, so you can etch a line. You can scratch a line on your work that you can see. Now, to make sure that you can see it, there's a couple ways to do this. Now, the traditional method is to use Dykem. This is for steel. It's red, and you paint it on, and it's like butyrate dope or something, but so it dries fast. And you got, usually it's blue. If you took shop class, you know, in high school, they had blue Dykem for your layout work. What a lot of guys are doing now, just take one of these big fat Sharpies and just, you know, color it in where you think your mark's going to be. And that's what I'll just do that, so I won't have to wait for the Dykem to dry. So I'm gonna put a center line on here, and then a cross center line, and then I'm gonna mark out the center hole, and the throw for the crank pin will be a 1/4 inch throw. It gives a 1/4 inch on the down and a 1/4 inch on the up for a 1/2 inch stroke on my steam engine. Of course, the stroke is how far the piston goes from top to bottom, right? So the throw is half of that. It's not marked on the diagram, although it has a picture of it. And I think somewhere in the text it said something like a 3/8 inch bore, 3/8 inch stroke, or 3/8 inch bore, 1/2 inch stroke. So that's what I'm going to do. So first of all, let's find the center of this. Measuring the overall height of this, the diameter, the highest point. Actually, I could do this way too. So that's 1 inch. I come up here to the 1 inch. 1, 2, 3, 4, 4. And then to get the rest of it, I read up here 1/40. One, 4, 6, 65, 66, 67, 68. Let's write that down. 1, 4, 6, 8. Alright. So now to divide that by 2. 1, 4, 6, 8 divided by 2. 0.734. That's an easy one. Verify it. 734. Alright. So that's the halfway point. So I set this, I'm going to set this now at 734. 7 and 34 thousandths. Now here's a cool thing you can do. You can tighten this, it's called the vernier, or fine adjustment. You tighten that down right there, and you move this vernier to get your 4, your 34. 30, 1, 2, 3, 4. Then you can lock it with this screw. You lock it right on the money. Sometimes when you lock it, it moves a little bit, so you gotta double check it there. Now you come back to your part, and you know that this is set at the dead center of this part. You hold it square to the surface plate. Scribe a line right across there. You see that line? That's my center point. And you can see the machining where I machined the little nib there. Just the tool made that little nib. And you can see that line went right through there. Now I'm going to clamp this because I want it to stay right there. And then what I'm going to do is subtract a 1/4 inch from that number, 734, and then I'll come down a 1/4 inch. That'll bring me down a 1/4 inch. Scribe a line, and that's where I'm going to mark the throw for the crank. Okay, I've put a little clamp on this now so it holds it for me. The center line is across there. I've got the clamp on. Center line is on. So now let's do the math here. 734 is where I am now. That's where the center line is. Minus a 1/4 inch, 0.25, equals 484. 0.484. I'm going to write that down just so I don't forget. Okay, that's the throw. So I'll subtract a 1/4 inch, and then 84. 84. Get it close. Tighten up the vernier. 484 right there. Clamp it down. Now that's going to be, I'm going to mark the throw. My clamp's getting in the way. Maybe I can show you that. Alright, there's my throw. So the only thing left to do now is to roll this 90 degrees and mark another center line at 90 degrees. And I can do that without messing the setup, because these blocks are square, so I just boom, that's it, right? Now the problem with that is it sets it up off the table, off the height, off the surface plate, some amount that I don't know. So all I'm going to do, I can find that out, go to the top, measure that, the highest point, 1, 2, 80, let's call it 280, 283, 2.083, right? And I know that the diameter is 1.468. I know the diameter is 1.468. So 2083 minus 468 gives me this distance here. Right, that distance is 615. So here's what it's measuring now. I know this is the diameter of the disc. So this is the difference. This is how much it went up because of the block. 615 has to be taken into account. So we want to come half the diameter. We already know that half the diameter is 734. Half the diameter is 734. So we add this height here from the table to the bottom is 615, and then come up half to get to the center. So here's where we're going to be. We're going to be 1.349, 9, 4, 13. 1.349 should put me right dead on the center, right there. So our 615 is already in there. So I'm just going to add 0.734, half the diameter. 1.349. All right, that's good. So let's set it up right here. Zoom you in a little bit. Just go to 1 inch, 1 inch 3. 49 with the vernier. 1, 3, 4, 9. That's right on. Lock it. Let me get it dead on here. All right. Here comes my mark. Let's see what it looks like. Oh yeah. See that? I don't know why it's not focusing. There it is. So there's my center line, and over here, here's the throw. I got a X marks the spot. I'm going to mark that with the punch, and then drill it 1/8 for the crank pin. So then, only thing left to do now on this is to I'm going to punch it. Punch it. What's that line from? Steve McQueen. So I don't want to crack my granite surface plate. So you want to do this over a good steady piece of the workbench, maybe where the leg is. And I'll use the spring-loaded punch. And to find that center line, I mean, you could take a magnifying glass or what have you. But I tell you what, a nice center punch will follow that line that you scribed in the middle. It'll follow it, and it'll stop. It'll bump up against the other line. So you can take that line and find it with your center punch. Kind of just let it float until and slide it along. It'll stop when it hits the next line. And the finer and lighter center punch that you have to do this little trick, the better. And you don't even really look, you do it by feel. Let's see if that's on there. Just the slightest punch to get started. Come on, focus. You see how that punch mark is right in the center? It's hard to see, isn't it? Let's do that again. So you use, this was a Rudy Kumpf. Rudy's was a great steam engine builder. He's passed away. But he taught me this. You see this little punch? So I bought a whole tool chest of a guy from his wife that he had passed away. And I got, every time I need something I don't have, he was a instrument maker and repairman. And boy, he had some great stuff. This is a tiny little punch. It's sensitive to your hands, so you can feel it. And you can feel these little lines in here. You draw your lines. This is going to give your center drill, when you drill this, this is going to give the center drill, you know, a place to start, so it doesn't wander and you get a dead accurate hole. Again, I'm just going to start along the line. It stopped. Boom. I didn't even look at it. I didn't even look. A little tap. Now you can see it. Alright, anyway, definitely got a good punch mark on there. Now, if I want to, I can go with a bigger, this spring-loaded automatic punch or whatever. Find that punch mark with this. And that thing jumped. I don't like those too much. That thing jumped way over. I had it perfect. I should have left well enough alone. See how it jumped? way over in the corner there. Oh well. Anyway, I can find it again when I have it set up in the drill press. I can find the good mark. So I've got the crosshairs. Okay, I'm over at the Enco mill now. I've got the flywheel, the soon-to-be flywheel. I've got two 1-inch parallel bars, also Enco, I believe. Bought a set of those. Those are handy. I just plopped the vise down here on the table and eyeballed it in. It's not squared. I didn't square it to the table. Not necessary, because I've got the marks. You know, I don't have to kill it just so it's tight. It's just got to hold it for the drill. And I'm going to make sure that this is flat. And a lot of times the movable jaw will rise up. So when you tighten it. So what you do in that case is you take you just snug it up a little bit. Then you take a mallet. You could take a lead hammer. And you knock it down until it is in good contact with the parallel bar. How do you tell it's in good contact? Parallel bar won't move. So this one, see, is tight. This one's loose. So there. Now you know that's the sides are parallel. Center drill. This is a hand tightening chuck. They're pretty handy. Get it? Ugh, bad. Let me traverse this table over. I don't have any power or anything. No DRO. Although I'd like to have a DRO. Now I have you on the ultra close-up. So the first thing I want to do is drill the dead center of the flywheel itself. So I'm checking this way. X, Y, and Z. So I can see that center line that I made earlier. I'm in pretty good position. And just give it a little tap and see where it comes in. So if this isn't centered, then the flywheel is going to wobble. And the steam engine won't self-start and stuff like that, and it'll shake. That looks pretty good. Now this is just the center hole, so I'm just doing drill. I'm not going to drill it through yet. Just do the center punch, center drill. That's just going to be an 1/8-inch hole. Okay, so that's done. So now I can use the hand wheels and come over a 1/4 inch and see if my line, see if it matches my layout line. These hand wheels have a movable 0. On the hand wheels, you can move the 0. See that collar? And of course I have the 0 marked with the Sharpie, bright red Sharpie, so I can count them as they go by. Let's see, I have my little scale here. For 1 turn, 0.125, 2 turns is 25 on these hand wheels. So I want to come this way on the Y. I believe this is the Y-axis. So I'm gonna feel my the slop. There's always slop in the screw. So I can feel that slop, and it's about 8,000. So now I'm at 0 now, so I'm going to re-zero it. taking the slop out. So 125, 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 125. Alright, that's an eighth of an inch. And go around again. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 125. Actually doing this through the camera, so let's see where we are compared to my mark. I don't know if you can see the mark. It looks good. I'm going to make a tiny little divot under power to see where I am. As long as it's smaller than an eighth of an inch, if it's off, it gets covered up. That looks real good. You can see the marks there in that shot. So go ahead and drill that. Alright, there's the holes, the center holes. Now all I gotta do is take the proper size drill bit and drill it out. I'm good to go.